Hi guys, you're listening to Sukriti and this video is about what on earth is a stereographic projection. A stereographic projection is defined as a two-dimensional representation of the three-dimensional spherical space. Now, what do we mean by that? It means that if you want to represent any vector lying anywhere in the three-dimensional space onto a paper, you need a stereographic projection. You might ask, why do we even need that? We need that because material science is full of properties that vary as a vector. That is, they have magnitude, but that magnitude varies as a function of direction. So we need a way to represent these properties along with their directions on a two-dimensional paper. And that is where a stereographic projection comes in handy. Now let's get into how do we draw a stereographic projection. On your screen you see a blue colored circle. Imagine that to be a three-dimensional sphere. OP vector is the vector we are interested in and we want to find its location on the equator. In order to do that, imagine a light source at the negative z point. Now consider a light ray going from the light source to the P point of the OP vector. This light ray intersects the equator at the point P prime given by x and y point. Now this P prime is the two-dimensional location of the three-dimensional OP vector. This way you can find the location of every vector in the z-positive hemisphere on this equator. This equator would then be called as a stereographic projection. Any location on the stereographic projection would then represent the vector direction of your vector, and the color that you represent that point with can represent the magnitude of your vector. And this way you can represent any property that changes with the vector direction onto a two-dimensional paper. I just want to add here that inverse pole figure and pole figure have all originated from stereographic projections. So if you understand stereographic projection well, you will be able to understand them as well.